Hi guys, so this is question number 2. It is a little bit similar to the question we were working on before. So we have here a combination of 10 numbers. These numbers are random. So we have the random numbers here. And what the question is asking for us is to calculate the mean, maximum, minimum, and standard deviation. So that's what we did in the previous question, but um, here we're also going to have some variation. So the question is asking for the discrete distribution. So the discrete distribution, we know that just like for small, like a little recap. In the previous question, we were talking about the normal distribution, the uniform distribution. So we saw that the uniform distribution was kind of like this, right? Like a block, and something was like uniform to happen. We gave this as an example, like so something would always like have the same, there was always going to be like the same probability of something happening. For example, if you roll a dice, the probability of getting the number 2 is like 1 chance in 6 because it has like 6 sides. Probability of getting number 5 is also like 1 chance in 6. Probability of getting 6 or 2 or 4 is the same, 1 in 6. So it's a uniform probability. Probability is like kind of like the same. We also saw, instead of the uniform distribution, we saw the normal distribution that was more like this, right? So in this case, we had like a higher probability of something to happen give with like a certain number, like so then like the highest would be here in the center, and then it could be higher, it also like could be lower, right? But the highest probability would be here in the center, and that's why we have like this mountain shape. That's terrible. You get the sense. Okay, so the mountain shape, perfect. So here in this exercise, we're talking about the discrete distribution. Oh, and in the normal distribution example that we gave was like a certain weight for baby to be born with. So you have preemies or babies that can be born with a lower weight, so it can be lower, and you have babies that can be born with a higher weight, but they're probably lower. But the probability of babies to be born at with a weight of 7.5 pounds is right here. So it's very high, and close to 7.5 is like higher as well. And when it gets like more weight gets lower, and less weight gets even lower. So the highest probability is in the center, and that's why we had this mountain shape. Here we're talking about the discrete distribution. And what the discrete distribution is that you have you have a certain number. You know there's gonna be higher than 0, and you know they can count. So it's gonna be something more defined. It's gonna be like yes or no, or a certain number that we have. So I added here. Let me close this. I added this picture here. So the sum of all the probabilities is also going to be 0. So that's very important to remember. And I'm going to show you guys, like when we create the boxes here, you know that the sum of all the probabilities needs to be equal to 1. If it's not 1, you know there's something wrong. So it's a good checkpoint for us. We can just go back and see what is that we did that we missed. And we also have here probability of each of the random variable is between 0 or 1. So just like we have here, we're going to have here. Okay, and in the discrete probability, you can have many examples like to follow, so you know that it's a certain name. So if you flip a coin, how many times can I get heads? Like if you flip it 100 times, how many times can I get head? So you know like the number, and if you like how many times did you do the laundry this month, so you can count, oh, 3, 4, 5 times, because it was like one act, one thing that you did. How many times did you go to school this time? It's like something like specific, and it's a number that you can count, as opposed to a distribution that is not a variable that is not discrete. They are continuous. So when you have continuous, it's an act that takes like sometimes it grabs like kind of like a period of time. So the probability is like a distribution of this interval. So that's where the difference is between discrete and continuous. So for example, if you ask how many times did you study for this class, it's a continuous amount of time. Or what was the speed of the car when it crossed a certain intersection? It was not like 50 miles per hour, because it had like fractions of the seconds there. So it varied a little bit, when it crossed the intersection. It was not like one single amount. So that's the difference for us. Now we can go ahead and start the question. So that was something like just interesting that I found. And I think that when we research like what's the meaning and what is the question asking, we can understand it better. It's better for us to understand. Okay, so what is the question asking? Question number 2. Giving the discrete distribution for fixed costs, unit cost, and demand for products with probability shown on the table below, using the random numbers given for each variable to conduct a sampling experiment to generate 10 profit estimates assuming the company sells everything that is produced and that the price of the product is set to 25.74. I highlighted this. The price is going to be very important, and the price is per unit. Calculate the main, minimum, maximum standard deviation and of the 10 profit estimate. Okay, so you have here the probability of having each fixed cost, the probability for each unit cost, and the probability for each demand amount. And you have random numbers generated. You want to know the fixed cost for this, random numbers, unit cost, and demand. So the first thing we can do, like, first of all, like I put some different colors here because I think it's easier for us to visualize and then assimilate. So first, what I like to do is just like to copy. We're gonna copy this, and you see that you have like the output here for demand. I'm gonna put the demand column right here below this column as well. So very organized. We're not gonna get lost this way. The unit cost I'm grabbing from here, gonna place it below the output for unit cost. And then the fixed cost amounts, I'm going the same. I'll place them below the fixed cost output. Okay, so now what we have to do is to create blanks to calculate the upper and lower bounds. So it's going to be 2 columns. I'm going to delete this. Okay, so this is going to be my lower bound. Need to start with the lower than upper, it doesn't matter, but it's better for if we keep like the same way always upper bound. Okay, this numbers here, I'm just gonna make sure that they're, let's see. Okay, perfect, that's what I wanted to. Decimal places. Okay, just gonna copy this, paste here. This one, sorry, green. And I'm gonna do the same here. Okay, copy this one, no paste here, and this one's yellow. Okay, perfect. So just to make sure that this one has 2 decimal places here as well, and 2 decimal places. Okay, so one thing here that we can start doing is we know that the lower bound always is gonna start with 0, so we can add 0 to all of them. You can just do like one part and then do the others. I prefer like to just do them all like at the same time. So the lower bound starts with 0. We know that. The upper bound is going to be equals our first probability. Oh, I got it too many. Okay, just 37. Let me fix the other. Okay, they're all fixed. So now we just like do with the others. Upper bound is equal to the first probability. So what does it say? Is it saying, let's see. Okay, perfect. So the probability of getting a demand of 600 is from 0 to 0 0.2, right? Just like we have here. The probability of getting a unit cost of $2 varies from 0. Maybe you're not gonna have from $2 to 13%. And the probability of getting a fixed cost of 7,000 is from 0 to 37%. So our second portion here, to have a fixed cost, not of 7,000, but of 8,000, it has to start with the same amount of the highest probability of the one before. So the probability of getting 8,000 is not 0, it's gonna be 37. Right? So you start with the highest probability for the previous one. So this equals the previous one. And then the probability of a unit cost of 3.4 needs to be the probability point of before. And then here for the demand, 1900 is 20%. Okay, that's perfect. And how are we gonna calculate the upper bound? So here's that where it changes a little bit, but so the probability of having a fixed cost of $8,000 is gonna be equals the lower bound, right? Or here is the same. You can select like any of these numbers because they're the same, plus the probability of getting the 8,000. So it's one plus the other, right? So that's 66. Okay. You can also add like these two numbers, or you can add this with this, it doesn't matter. So minus plus exactly. And then you have it, and for this numbers here, we can just fill them below. Double clicking and it works. Okay, so this portion is complete already. So to facilitate our calculation, I'm gonna write here our price that we saw. It was set to 25.74. So I'm gonna write the price 25.74. Okay, so now we can go to the actual calculations. So you can start here calculating the profit. I just prefer like to fill those columns and then we go to the profit section. So we're given the random numbers. We're given the random numbers here and we want to find what is the probability, what's the outcome of with like this probability here. What's going to be the fixed cost if you're in this probability. So you could do this like manually and look like, okay, do this, okay. Okay, so just for us like to have an idea, something that you could do is see, okay, it's 0.05. So where is 0.05 here? 83.21, it's 0.66 to 83. It's between 37% and 66%, or it's between 0% and 37%. Okay, it's between 0% and 37%. So the fixed cost would be 7,000. So we would just write 7,000 here, right? So yes, you could do this manually, but there's an easier way to do this, and we're gonna use the VLOOKUP formula because in this case, for example, we just have like four amounts, but we could have like a much higher like interval, and it's just gonna make our lives easier and also like avoid mistakes. So one thing to notice is that you see it's not giving like 37% or 0% or 66% or 83%. The numbers here are like between this upper and lower bounds. So because they're between the upper and lower bounds, we're not gonna use an exact match. When we use the VLOOKUP, we're gonna use the approximate match. So instead of the $7,000 years, I'm just gonna delete this equals VLOOKUP. So what is the number that you wanna look up? So the lookup value is gonna be this amount and the table array. So where do you wanna find these amounts? So you're gonna select all the amounts, right? And then you're gonna have to give like column index number. So in which column is the number that you want to return? Like the answer is going to come from which column? Column number 1, do you want to have like this column here? No. Do you want to have like this column number 2? Return the amount of upper bound? No, you want to return the amount of the fixed cost. It's asking for the fixed cost related to this interval. So this is column number 3, and then the most important thing is, like I mentioned before, you're gonna select false for exact match or true for approximate match, and we're gonna put true because of that. And now you find the same $7,000 that we found before. So you have an A here. Why is that? Because when I drag this down, the amounts of the table here are being dragged down as well. So we have to lock these numbers. On to lock, I'm just gonna do my Mac Fn and F4, Fn and F4. Okay, so they're locked. Perfect. So now you can drag them down. I'm not locking the number 3, and I'm not locking the, of course, the lookup amount. Okay, so one thing that you could do here is just like copy here and like copying the formula would work. You could just copy this formula here. Oh, okay, and then change because you see that it's not E anymore. It's gonna be H to J. So H to J. And drag it out, or you could just write find the numbers or write the lookup formula again. Equals the lookup, the amount, the number that you want to look up is this one. And where do you want to find this number? Between here. And I want to return to the amount of column number 3 here, unit cost. And I want this to be an approximate match. So true. And we have to remember to lock the numbers. F and F4, F and F4. Okay, perfect. So the same thing, I want to find this probability of happening 78%, and this amounts here. I want to return to the amount in column number 3, and I want this to be an approximate match. Okay, and we mark the numbers. Okay, so now we have our 3 columns calculated. And now to calculate our profit. So one thing to remember is that to calculate the profit, what is the profit? So the profit's going to be our revenue and minus our costs, right? But in this example, we have fixed costs that don't vary. So you can do like the revenue minus the fixed cost. But you also have the unit cost here. So the unit cost is variable, like it depends on the amount of products that you produce. So it depends on the demand. So you're gonna have the fixed cost, for example, $7,000, that's not gonna change. And you're also gonna have a variable cost that is, for example, I'm gonna put in the same. A variable cost is gonna be the unit cost times the demand. So this is fixed. And this is variable. Okay, so these two costs here, the fixed and the variable, are gonna give us the total cost. Right? Equals and you have this total cost here. Okay, so our profit is gonna be our revenue minus the total cost. So that's just like for us to understand. We're not gonna do that, but just like for us to remember that we have to take into account this calculation here as well. So we know that the formula is gonna be revenue. Sorry, profit equals revenue minus total cost, right? Or have revenue minus cost of goods sold if you're accounting. But okay, so how do we calculate our revenue? We have the unit price here, right? So unit price times the demand. If you sell 4,900 units times 25.72, that's going to be our profit, our revenue, sorry. And then from our revenue, you're going to deduct the cost, the fixed cost, and also the variable cost, which depends on the demand as well. So instead of using this calculation here, we're just gonna do like one simple formula here. So we already typed the price to make it easier. Remember to anchor the price. So when you drag it down, the price is always gonna be grabbing like from here and not gonna grab like from this amount here. So just gonna write the formula. So equals revenue. I'm gonna get the price here times demand. This is gonna be our revenue. And then here I'm gonna deduct the cost. It's gonna be the fixed cost. Okay. Or you can go like the cost first. This one times the demand. Okay, plus the fixed cost. I'm going to anchor the price. Okay. Okay, so that was very easy to calculate. We remember here now, and that's the last portion of our question, and we know like how to calculate the rest. So mu is equals average. Calculate the average of the profit. Everything's gonna be based on the profit. Equals max on the profit as well. Mean of the profit. Standard deviation. We're using S because it's a sample, it's not a very large. No, it's not a population. Okay. So now our question is complete. Thank you guys. It's complete. So now we can move to question number 3 next.